All right, welcome back to Intro to Statistics. We're going to be talking about correlation coefficients and scatter plots and all of that kind of fun stuff. Okay, so let's see. This problem talks about foot ulcers are a common problem for people with diabetics. Higher skin temperatures on the foot indicates an increased risk of ulcers. Okay, so a study performed at the Colorado School of Mines. Skin temperatures of both feet were measured in degrees Fahrenheit for 8 diabetic patients, and then we're given the following table. Okay, if I was to pick a problem where it says, "Hey, what kind of problem would you pick?" You're looking at a good example of a problem I would pick. Okay, I think I've picked this type of problem. I think I've picked this exact problem for previous classes for having their exams. So it's not too bad because the numbers are or they're not exactly the same. And there's not too many of them, so that's a nice thing to do as well. Okay, it's not like we're talking about 15 football players. We have we have 8 diabetic patients here. Okay, so it says okay, we're going to go ahead and do a scatter plot. So we're going to use the point plot tool, and I hope you guys have this. All we're going to do is we're just going to be plotting points here. So we have the first one is 85, 85, and I'm just going to type that in there. Say 85. My Y value is 85. Oops. Tab 85. Plot the point. And then we're just going to go through in turn and plot them everywhere. I'm just going to go ahead and pause that so you don't have to watch me do it. Okay, so all I did here was just plot the 2 points here. That's vaguely linear-ish. Why they decided that the independent variable should be the left foot temperature and the dependent variable should be the right foot temperature. I'm going to leave that up to the people, to the folks who know diabetes better, and they must have had their reasons to pick this one. Maybe it was arbitrary, but I'm not qualified to argue with them. So I'm going to take the expert's opinion on this and say, okay, if you guys want to say the left foot predicts the right foot, I'm okay with that because I don't know enough to know better, and that seems like a reasonable thing to me. Okay, so all I did was plot these points in here. We're going to check, fingers are crossed. Okay, and they said that's fine. Okay, calculate the correlation coefficient. I'm sorry. Between the two temperatures, round the nearest 3 decimal places. All I'm going to do is I'm going to go to my calculator, and we're just going to say we're going to go to stat. We're going to clear the list. So I'm just going to clear list 1. Okay, and clear list 2. Enter. Okay, and then I'm going to go back to stat, and I'm going to edit. And we're just going to type in the things here. So I'm going to go back to list 1. What we have here, we have 85, 89, 87, 80, 80, 86, 76, 88. And it's 8 of them. Okay. Now we're going to move over. I would recommend don't go up to where it says L1, L2. Stay down in the work section. Don't go up there. But we have 85, 87, 82, 81, 80, 85, 80, 89. So we're good. Okay. And however long it takes you to type that in, again, I could work with a friend with this and double check just to make sure that we're both getting the same numbers. I probably would. Okay, because that nobody, nobody is above the typing in 89 when they meant 98. Okay, that's just it's a thing that happens. I don't want to penalize you for those kinds of mistakes. Unfortunately, that's the kind of realm we are in. So we're going to go to stat. We're going to go to tests. Okay, and I'm going to go all the way down to where it says lin reg t-test because on a TI 83, that's how we get correlation coefficient. Okay, so X is L1, Y is L2. Sounds good to me. We're going to leave beta and rho alone. Okay, and then we're just going to go ahead and calculate. There's eventually there's things that are going to be taking advantage of us knowing this, but we're in chapter 4. This is not that time. All right, so we're going to be here And we have an R. What did they say? But they wanted, how many decimal places did they want? Let's see here. They want 3 decimal places. We'll go back to here. We'll say that's going to be 0.83, I guess 0.835. This 6 is going to round this 4 to a 5. So we're going to say 0.835. So 0.835. Okay, I've had enough nurses in the last couple of years doing this that they get mad if I don't include the leading zeros. So I will include those leading zeros so that the nursing people will be happy about the fact that I'm putting numbers in properly. Okay, and now the computer is happy with it. Sometimes it used to yell at me to say, hey, you didn't need that. But like I said, the nursing students really like when I put in that leading zero. So let's make them happy. And then we'll work with that. Notice the correlation is positive. So if the left foot is cooler than average, then I would expect the right foot to also be cooler than average because they are going up together or they're going down together. So I would expect the patient's right foot to be cooler than average since R is positive. Okay, if it's opposite, then they're going to go in opposite directions. Okay, since the R is going to be positive. Okay, so like I said, if you said, hey, I need you to pick a problem that might be on a quiz right now. Well, first off, Colorado School of Mines. I graduated from a School of Mines. We got us together a little bit. So New Mexico School of Mines, Colorado School of Mines. Okay, their chili is not as good, but whatever. Other than that, but it's only 8 problems. The numbers are reasonably not too close to each other, but there's only eight numbers there, so that seems to be like that's a good problem I would pick. And I know a lot of nurses take this class. I know people that are going into nursing take this class, so I will tend to pick medical data over like football player weight and height. There's nothing wrong with that either, but I just figured, well, a lot of medical professionals are going to be looking at this. Let's give you experience looking at diabetes data. Okay, so we could always do that. Best interpretation of a correlation coefficient. Some people have warmer feet than others. People who have warmer left foot generally have warmer right feet. Okay, that sounds pretty good. The warmer the patient's left foot, then the patient's right foot become warmer. I don't know if I believe that, right? Just because this foot it's kind of the way this is written, the way I would interpret this in English is kind of saying that the left foot is causing the right foot to become warmer. I don't think I would go with that. If we call the patient's left foot, then the right foot become normal. Again, that would be a negative number for correlation coefficient. That's not really going to work out that way. So I would say, yeah, some people, maybe they just run a little hot. Okay, they run a little warm. So some people have warmer feet than others. If they have warmer left foot, then they generally have warmer right feet as well. And we'll go with that. Okay, so there we go. That's the kind of problem that we're going to get. Like I said, I like this problem. If I had to pick a problem right now for a quiz, this would be it. All right. So I'll let you go with that. Hopefully this is starting to make a little bit more sense, and hopefully you're not spending too much time typing these numbers in and trying to get this to come out right. I don't think this is a terrible problem. Like the football problem I thought was not as good. This problem only has 8 people in it rather than 15. So, and the numbers are reasonably, they're different enough that you're not going to get lost in them. So I'll say goodbye with this one and let you guys get started on your homework. It's a good problem. I would like this one. All right. See you in the next video. Thank you.